Welcome to Industrial PLC Applications. This video is the second in a series called First Steps, and we'll be focusing on creating rungs and instructions. Okay, welcome back. We're now going to create our first actual rung of logic. Now, in order to do that, you have to be in the editor screen, you have to be offline, and this first section here, I'm going to point a few things out. This is our rung number. We can add more rungs by highlighting the first one, and then this H symbol is a new rung. If you move your cursor over to any of these instructions on our menu bar and wait, it'll tell you what that particular instruction is. So I can create, if I wish, I can create a couple of extra rungs just by clicking on it. It's not a great practice to start making rungs ahead of time. Not for this particular model of processor or software, but other processors do not allow you to have a blank, empty rung. This rung would be number 2, for example, and all 3 of them actually would be dead shorts, and it will create major faults. If the software is, depending on the software you use, some of them will catch that and not allow you to download it to the processor. This particular program you can use and have blank rungs, but it's like they say in England, in bad form, old chap, bad form. So let's not try to get ahead of ourselves. We're just going to delete those. So we're going to add some particular contacts, and the base contact that's used are, first of all, they're found, these are particular ones are favorites. You can add more contacts later. If you like the particular instruction, you can add those instructions later. This is all the bit level instructions. These basically only work on a single bool, a single 1 or 0 within the memory structure. So any one of these instructions, all you're doing is working on that single solitary bit. So the rung itself is divided into kind of 3 rough areas I like to call the ABCs. Oh, you're not going to drop down for me. And what happens is, basically, the section closest to the left-hand rail I like to call the A section. That's all the activation I need. If I want to get my rung to start, that's where my first steps are going to go to make the rung, activate the rung. And the second section, I call it the B section. That's where I build it out. I put the block instructions. I do all the business of the rung itself. And the last part is way off to the right, and it's the conclusion. What did we do? What did A and B together give us our conclusion C? So there, I'm going to put this rung, and you can see it populated right over on the right hand rail. So outputs are should always be on the right hand rail. If you were looking at some of the videos I have on relay logic, you would find that with relay logic you could have the overload contacts from a motor starter follow the motor starter coil. Here you cannot put another in. If I try to drag this contact, it will not let me do that. It says no, you can't put that there. The only place it's allowed is where you see the plus signs pop up. So it's not going to let me put it there as much as I really want to. It won't let you do that. Once you've got a couple of instructions on the rung, and you can see that was quite simple, you'll see there's yellow attention triangles. Now these yellow attention triangles are warnings saying that if you try to download this to a processor, you're going to have something called a build error. And I'm going to go to my device, and I'm going to actually show you what a build error looks like. I'm going to build this program, and down on the bottom you will see that it starts to generate it, and it'll say, whoa, 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 hang on a second, you've got some problems here. I have 3 errors, and it's saying expecting a bool variable or a bool constant. It tells you the file and the line it's in, the column you'll find it, and the project. So if you have a long program and you just happen to miss one of these, you just simply have to double click on this report and it will jump and take you directly to the contact or the problem that you've overlooked. I'm not going to say you created a problem. It's probably not intentional, but these things happen. There's one I'm going to show you that happens quite often, actually. So we're going to use some inputs and outputs, which is straightforward. There's a couple of ways we can do giving this an identification for this particular instruction. So I can either right click on the tension triangle. Okay, it's not letting me do that on the instruction. Okay, I'll go with that. And it says variable selector. Now the variable selector gives you the opportunity to use any variable that is within the memory of the PLC itself. So each of these, a bool is a single bit. This instruction works on only a single bit. So I could select any one of these. Now the first ones that you start off with from the bottom and you work your way back up to the top, it has the underscore SYS VA underscore KV BPERR. And what that is, anything that starts with a sysval, it's short for system value, they're actually tracked by the CPU of the processor, and if there's an error that will be reported there, you can use it. Like you can use the first scan. So the very first time it does something, it will initiate something for you because it's the very first scan in that particular operation. If you abort a cycle, power up bit, all of these things are at your disposal. The ones that we're interested though are either inputs or outputs. And on each of the micro 850s, there's a set number of inputs and outputs to the initial host model. The 24QBB, for example, has 10 outputs and 14 inputs. So with this particular one, you can see we got to remember that 0 is a placeholder. We go from digital input 00 up to digital input 13. And this translates to underscore input output underscore embedded module underscore digital input underscore the actual contact itself, the terminal screw 09. When it has DO, that's a digital output, and you can see that I go from 00 to 09, which gives me my 10. And everybody forgets that 0 is a placeholder and we have to account for it, and everything gets shifted by 1. So what we're going to do is I'm going to assign it, just because it's here, digital input 00, and if I were to hit OK, it would populate the blue box part, which you'll see in a second, on the instruction itself. But this alias gives me the opportunity to give the contact a name that I can remember, because underscore IO underscore EM underscore DI underscore 00, not only is it a tongue twister, it's hard to remember. So I'm going to type in here start push button. You can put almost anything in here. Make a habit of putting underscores, that way it doesn't get a problem. Once you've used a description, an alias once, it cannot be repeated in the program. Now I should also point out that there are two different areas where variables are stored and are cataloged. And up here in the top it says the word scope. So if we look to our left at our project organizer, we can see that we have my first program when we have local variables, and below it we have another spreadsheet symbol saying global variables. This micro 850 is the global variables, and global variables can be used by any program. So all of your inputs and outputs, all of your system bits, they can be used by any program that requires access to that. I'm going to press OK, And I'm going to go to the next one, and you'll see we've got the blue little box, and I get a drop down where I can access directly the next bit. It won't have an alias because I did not open it in the variable selector. Keep this in mind, however. You saw how easy it was for me to put that input. If I go over to my output and I put the drop down, notice that these system values are shown because we can write to them. An output, you do a write instruction. Below it, we have the actual physical outputs that the processor can manipulate and turn on. I've seen it happen, been there, done that, wasn't paying attention. By using the variable selector here, you can run into a bit of trouble. So if I leave it this way, I'm okay because it's an output. I'm going to right click and go to variable selector, and by default it'll go to the number I came from. But if I hadn't done that, I could be looking for 00, not pay attention, and go, oh, here it is. It's my start push button. No alias, nothing to identify that. I click on it, hit OK. It says, oh, that's fine, no problem. You can have digital input on an output. There's no yellow attention triangle. But let's watch what happens when I build it. Expecting an output or memory bool variable. If I double click that, it's now saying this doesn't make sense. You have an input and an output instruction location. So I can hit select variable, or I can just simply use the drop down and use the real world output. And if I were to build it again, it would accept this. So this is basically a first run. If my start push is on, and I'm going to make mention of this. If this particular was a start button, and I'm going to go to my variable selector, I'm going to give it a variable name. If I had a stop push button, when I press the start, this should energize. Now that looks counterintuitive because this and this are normally open contacts. That's the way, as an electrician, you're trained. When you see that symbol, when you see this symbol, you know that's normally open. If you see it with a cross through it, it's normally closed. Now this is one of those things that confuses quite a few people, and I've run into lots and lots of skilled electricians who it just throws them for a loop because it doesn't make sense. It seems to be counterintuitive. But I'm in the next little portion, I'm going to explain exactly why this is the correct one for a stop push button. I'm going to create a new rung, and I'm going to put it on top of my first one. You can see I've got the plus sign that allows me to do that by dragging and dropping it. And I'm going to use a program control, and I'm going to put something called a NOP instruction. Now when I put the mouse over it, it says no operation. It is a placeholder. It is an odd instruction in that it can be anywhere on my rung, A, B, or C. It doesn't make any difference. It does not get executed because it doesn't do any operation. What it does is it creates a placeholder. So if you're creating some branches, but you just want to put the branches in ahead of time, but you don't want it to jump out other things, you can put the NOP instruction in it. There's another way you can prevent the rung from being scanned, which I'll cover in defeating a branch or defeating a contact safely. And for test purposes, it's great. I like to use this, and the students I teach, I make it mandatory for them to do this. Up on this little blue box above that is a place to write commentary. So I'm going to double click on it until I get my flashing cursor, and you can see I've got selected Arial Narrow 12, and my first program with my name. it's a great place to provide information, and I call this a header rung. So when I finish the project, I can write a blurb and says, okay, I've got over here, I might have 12 small programs. They'll follow one after another, and if I have them numbered 1 to 12, nobody knows what program 7 does. So this gives me the opportunity. It does not impact my scan time. It does not impact my program flow. I can turn around and say, this is my first program. This program allows the clamps to close on the part. This program monitors the photo eyes looking for the part on the conveyor. Whatever the program does, it allows you to take a big project, put it into smaller chunks, smaller, digestible, quick, easy to troubleshoot batch of rungs of logic, and then identify it. As I say, it doesn't impact that, but it gives you the opportunity to put in some commentary. As a seasoned electrician, I can't tell you the number of times, especially first generation of PLCs that I worked with back in the late 80s, early 90s, there was no commentary on the screen. You had to have huge books, and when you had just as cryptic a description as these to try to figure out what the program's doing, it really slowed things down. When they first introduced commentary on instructions and commentary on rungs, it was great, but you had to have those installed on the laptop. Now they're part and parcel of the memory. When you save this to the processor, those comments are being saved with it, so that when you export the ARC file, someone else can look at it, upload the program, and all the commentary is there. So in the second rung, I'm going to put in when the start the output I mean, it's as simple as that. It does not have to be an elaborate comment, but something definitely to give the next person a clue. And if you work with PLCs for quite a bit in a large industrial environment, you could have 100 or 200 of these PLCs, and you go back to a place you haven't been to in 6 months, doesn't matter how young your brain is, you're going to forget. This is like, oh, I remember, okay, yep. Because you can change these anytime you want, and I can date stamp this. So, okay, if I have a log, I can go back, look at my log, or I can turn around and say revised at such and such a date. And the beauty of that is, if you're keeping a log, or you can go back. Let's say you were doing a temporary project, it's run its course, it didn't do what you wanted it to do, you want to restore it. I can add a comment like this is May 7, 2024, but so this tells, oh, August 23, go back, get the one that's dated August 23, and you can restore it, and everybody's a happy camper. Nothing transpired. In our next video, we're going to dive into the instructions that we used, and how they perform and what their functions are, their key core functions. Just before we go, I'm going to show you something that is quite handy. There's two little arrows here on the upper left corner of our workspace, and if I press the first one, you're going to see that my instruction menu has disappeared. So if you click by mistake, you can't find it, just look for the two arrows, boom, it's back. If you the one below it though is actually a step back in time for an old guy like me. When you click that on, you're going to get this cryptic kind of, well, it looks like alphabet soup. What if this is, when they first were doing programming a lot of the programmers were writing it literally in ASCII, which is the American Standard Computer Instruction Interface. So you would know, you type a T, it has a particular code number, but this is what they would type. And the number 1 is the first rung of logic, the number 2 is the second rung of logic. The parts in blue are the mnemonic that represents the instruction, and they every instruction has a mnemonic. We'll go through them as we introduce more instructions, but this was, you could actually type an entire rung of logic if you were very quick with the keyboard, including branches, nests, and all kinds of stuff, and hit enter, boom, and it was done. When addressing was easier and simpler, I used to do that quite often because it was very, very fast and I knew exactly what I was after. But it's a throwback, and I'm going to refer back to this because there's a few times this editor comes in handy. So I'm going to leave it at that. You can see that we followed our instructions. There's our NOP. So this instruction here is called an XIC, and we have this output over here, which is called an OTE, and our next quick little video is going to explain exactly how those instructions work. In the next part of our first step series, part 3, we're going to take a deeper look at the instructions we've used in this previous program we just created.